There is a canyon in the American Southwest where two states meet at the bottom of a river. For millions of years, the Colorado River carved through that canyon. Wild, unpredictable, and completely untamable. In spring, it flooded farmland across 3 states. In summer, it ran dry. It answered to nothing and no one. Then, during the worst economic crisis in American history, when a quarter of the country was unemployed and the nation was on the verge of collapse, the United States government decided to do something that most engineers said was impossible. They decided to stop that river. Not redirect it. Not manage it. Stop it. Completely. What followed was 5 years of construction so brutal, so relentless, and so dangerous that it has never been fully replicated. Workers toiled in temperatures exceeding 130 degrees Fahrenheit. Men died from heat, from falling rock, from dynamite, from carbon monoxide poisoning. They worked in shifts around the clock, 24 hours a day, 7 days a week, because stopping meant losing the river. And when it was done, the tallest dam ever built. A structure so massive it altered the geography of the American West permanently. This is how America built the Hoover Dam. To understand why the Hoover Dam was built, you first have to understand what the Colorado River was before it existed. The Colorado drains an area of roughly 250,000 square miles, stretching from the Rocky Mountains of Colorado through Utah, Arizona, Nevada, and California before emptying into the Gulf of California in Mexico. It is one of the most powerful rivers in North America. Over millions of years, it carved the Grand Canyon, 1 mile deep, 277 miles long, through solid rock. And it was completely unpredictable. In the early 20th century, the American Southwest was undergoing explosive agricultural development. Farmers in California's Imperial Valley had diverted Colorado River water to irrigate what would become some of the most productive farmland in the world. But in 1905, the river flooded catastrophically, breaking through irrigation canals and flooding the entire Imperial Valley for nearly 2 years. The resulting inland sea, the Salton Sea, still exists today. Downstream communities lived in constant fear. Cities were growing. Population was exploding. And the Colorado, wild, seasonal, violent, could not sustain the American West's ambitions. Something had to control it. The idea of damming the Colorado had been discussed since the 1900s, but the scale of what would be required was almost incomprehensible. The Bureau of Reclamation, the federal agency responsible for water infrastructure in the American West, spent years surveying potential dam sites. Engineers hiked through remote desert canyons in scorching heat, mapping geology, measuring river flow, testing rock formations. They settled on Black Canyon, a narrow gorge on the Nevada-Arizona border where the canyon walls were solid volcanic rock capable of supporting an unprecedented structure. The dam they proposed was unlike anything ever attempted. 726 feet tall, nearly twice the height of any dam previously built. 1,244 feet wide at the crest. 660 feet thick at the base, the width of 2 city blocks. 4.4 million cubic yards of concrete, enough to pave a 2-lane highway from New York City to San Francisco. The reservoir it would create, Lake Mead, would be the largest man-made lake in the United States, holding enough water to cover the entire state of Pennsylvania 1 foot deep. Congress authorized the project in 1928. The contract was awarded in 1931, and the pressure to deliver it on time, in the middle of the Great Depression, was unlike anything American construction had ever experienced. When the construction contract was announced in 1931, America was in freefall. Unemployment had reached 25%. Banks were failing. Families were losing everything. Breadlines stretched around city blocks from coast to coast. The Hoover Dam project was, for tens of thousands of Americans, the difference between survival and despair. Within weeks of the contract announcement, over 10,000 men descended on the Nevada desert. They came from every state. Some walked hundreds of miles. They built makeshift camps, tents and cardboard shelters in the desert heat, just to be close enough to apply for a job. The company that won the construction contract, a consortium called 6 companies, could only employ around 5,000 men at any given time. The rest waited. Those who got jobs entered a world of almost incomprehensible physical demand. The canyon floor in summer reached temperatures of 130 degrees Fahrenheit. There was no air conditioning, no shade in the canyon. The work was continuous, blasting, drilling, pouring concrete, in conditions that would be considered unconscionable by modern standards. Workers died from heat stroke, from dynamite accidents, from falling rock, from carbon monoxide poisoning when gasoline-powered trucks operated in the enclosed canyon. The official death toll was 96 workers. Historians believe the true number was significantly higher. These men, forgotten by the economy, driven by desperation, built one of the greatest engineering achievements in American history. Before a single cubic yard of concrete could be poured, the workers had to solve an engineering problem that had never been attempted at this scale. They had to move the Colorado River. Not a small river, not a seasonal stream. The Colorado, one of the most powerful rivers in North America. The solution was 4 diversion tunnels, 2 on the Nevada side of the canyon, 2 on the Arizona side, each one 56 feet in diameter and over 4,000 feet long. Together, they would redirect the entire flow of the Colorado River around the construction site while the dam was built in the dry riverbed. Workers drilled into the canyon walls using jackhammers mounted on truck-mounted drilling rigs called jumbo drills, a technology invented specifically for this project. Teams of 30 or 40 men worked simultaneously on the tunnel face, drilling holes in precise patterns, packing them with dynamite, retreating, blasting, clearing debris, and advancing. The work was suffocating. The tunnels filled with exhaust fumes from gasoline equipment. Workers suffered chronic respiratory damage. Some died, but the tunnels were completed. In November 1932, engineers triggered the diversion. The river, the wild, powerful Colorado, was redirected. The riverbed went dry, and for the first time in geological history, the floor of Black Canyon was exposed to open air. Now the real work began. First, workers had to excavate the canyon floor down to bedrock, removing all the loose sediment the river had deposited over thousands of years. High-pressure water jets blasted the canyon walls clean. Workers hanging from the cliff faces on rope harnesses, called high scalers, removed loose rock with jackhammers and dynamite, inch by inch. Then came the concrete, for 0.4 million cubic yards of it, poured continuously, around the clock. Here is where the engineers faced a physics problem that threatened the entire project. Concrete generates heat as it cures. The mass of concrete required for the Hoover Dam was so enormous that engineers calculated it would take 125 years to cool naturally, by which time the thermal stress inside the structure would have cracked it beyond repair. The solution was extraordinary. Engineers embedded a network of thin steel pipes, over 582 miles of them, throughout the concrete structure. Cold water from a refrigeration plant was continuously pumped through these pipes, cooling the concrete from the inside as it cured. The dam was poured not as one massive block, but as a series of interlocking columns, over 200 of them, each one curing and cooling independently before being grouted together into the final monolithic structure. It was a concrete engineering system developed specifically for this dam, and it worked. Let's stop for a moment and put the Hoover Dam in perspective. 726 feet tall from foundation to crest. That is taller than a 60-story skyscraper. 1,244 feet wide at the top. You could drive nearly a quarter-mile across it. 660 feet thick at the base. The bottom of this dam is wider than 2 city blocks placed side by side. For 0.4 million cubic yards of concrete. Enough to build a sidewalk that would circle the entire Earth at the equator. 17 turbines generating up to 2,080 megawatts of electricity, powering Las Vegas, Los Angeles, Phoenix, and much of the American Southwest for decades. Lake Mead, the reservoir created behind the dam, can hold 26.12 million acre-feet of water. That is enough water to cover the entire state of California to a depth of 1 foot. The project was completed 2 years ahead of schedule, in the middle of the Great Depression, with hand tools, dynamite, and the raw physical labor of thousands of desperate men. No project of comparable scale has been completed faster before or since. But behind every number, behind every engineering achievement, behind every superlative, there are men. Workers who came to Black Canyon with nothing but their willingness to work, who endured conditions that would be illegal today, who died in ways that were covered up, minimized, or simply never recorded. The official death toll of 96 workers does not include the dozens of men who died from heat stroke in the years following construction, deaths that 6 companies refused to classify as work-related. It does not include the workers who died from silicosis, a lung disease caused by breathing rock dust in the tunnels, because the condition was not recognized until years later. It does not include the first recorded death, a man named J.G. Tierney, a Bureau of Reclamation surveyor who drowned in the Colorado River on December 20th, 1922, while scouting the dam site. His son Patrick Tierney would become the last recorded death on the project, falling from an intake tower on December 20th, 1935. Exactly 13 years later, to the day, the Hoover Dam was built by men the Depression had made invisible. They are remembered now not in the official histories of engineering, but in the stone and concrete of the canyon itself, in a structure that has stood for 90 years, and will stand for 1,000 more. The Hoover Dam changed America, not metaphorically, literally, physically, permanently. Before the dam, the American Southwest was a hostile, water-scarce desert. After the dam, it became one of the most rapidly developed regions on Earth. Las Vegas, a small railroad town of 5,000 people in 1930, now has a metropolitan population of 2.2 million. Its entire existence depends on Hoover Dam power and Colorado River water. Los Angeles, already large in 1935, used Hoover Dam electricity to fuel its post-war industrial and population explosion. The dam helped make Southern California the economic engine of the American century. Phoenix, Tucson, Boulder City, entire cities that exist because of the water and power the Hoover Dam made available. Beyond the American Southwest, the Hoover Dam changed what the world believed was possible in construction. Every major dam project built in the 20th century, the Aswan High Dam in Egypt, the Three Gorges Dam in China, the Itaipu Dam in Brazil, was influenced by the techniques, the engineering, and the institutional knowledge generated at Black Canyon between 1931 and 1936. The Hoover Dam was not just a dam. It was a proof of concept, a demonstration that human engineering, at sufficient scale, with sufficient will, could reshape the natural world itself. Today, if you stand at the top of the Hoover Dam and look downstream, you see the Colorado River flowing beneath you, controlled, measured, allocated, managed. Released in precise quantities by men in control rooms, according to interstate water agreements, to serve the needs of 40 million people across 7 states and 2 countries. The wild river is gone. The river that flooded the Imperial Valley. The river that carved the Grand Canyon. The river that no one could stop. It was stopped by men with hand drills and dynamite, in 130-degree heat, hanging from canyon walls on rope harnesses, during the worst economic crisis in American history. The Hoover Dam stands today as it has stood since 1936. 90 years of continuous operation. 90 years of water and power flowing to cities that should not exist in a desert. And in the canyon below it, the river runs on. Smaller now, managed, humbled, but still moving. Because even the most powerful dam ever built by human hands cannot stop a river forever. It can only hold it back, for now.